So now that we've seen a bunch of different scheduling algorithms, what I want to talk about is some overall high-level systems that actually use them. So here, first of all, we're going to talk about what is called a multi-level queuing scheduler. So the idea is this. I have basically two types of tasks. I have background tasks and I have foreground tasks. A foreground task is something I need to work on immediately, right? Something that's right in front of me, right? I need to get this result. Maybe it's something like the user is, saving a file, right, or compressing a video. That's going to be a foreground task because it's something I need the result for right now. The other thing I have, right, is a background task. A background task is something that's going to sit around, right, for the right time, and then it's going to run. You could have a background task like, for example, the defragger, right? That's kind of a background task, right? The system's going to wait until 2 a.m. in the morning, and then it's going to do its defragmentation, right? And then it's going to do its patching, that type of thing. So that's a background task. And so we have really the spectrum from basically from background to foreground. And what's specifying is a priority, right? The foreground things get to go first, the background things get to go later. So in general, if you think about it, right, these types of tasks, right, are really different, right? The task that needs to be immediately done versus a task that can be done kind of in the background, some other time later on. These things are really different. It's not really going to be fair to schedule them using the same schedule, right? It's not really going to work out. And so the idea is that we basically can break our jobs into these different categories. And so I have this image on the right-hand side. What this is showing basically is different categories of things that are basically from highest priority to lowest priority, right? So this is where we have kind of this multi-level term coming in there. The idea is, right, I'm going to classify my processes a certain way. So at the top, I have the things that have the highest priority. These are system processes. So this could be something really, really basic, like reading from the keyboard or writing to the graphics driver, right? Something that's really key and needs to happen. Otherwise, the user thinks the whole system is frozen. Then we have interactive processes. So these kind of are similar. The idea is that this is something maybe the user is interacting with, and the user wants feedback right now, right? They can't wait around, right? We need to kind of prioritize them over our background tasks because they're actively working on something. Then I get further down, I get batch processes. So this is stuff that's maybe been like scheduled. So like, oh, I need to run these 20 jobs, and that's kind of, I'm going to schedule it. I'm going to do it later on, sometime later in the day, right? So maybe it will run when the user's still active, right? But it's kind of scheduled. It doesn't need to be done just this moment. It needs to be done in a few hours. So that's a different type. The last type, right, is super low priority, right? Things that maybe are super background tasks that nobody needs to really worry about. So for example, some of maybe performance tuning stuff, right? That's maybe not really it's kind of like optional, right? Maybe Windows leaves that for the end. Or here, right, they had student process was listed, which I think is a little bit funny. So somehow it's like this has a little bit of feeling of like if you were running on like the ASU big server, right? It's like everybody gets to go first, right? Faculty and staff and then all of a sudden students are the lowest priority. So it seems a little bit like this is maybe how the ASU server works. So yeah, I thought there was a nice little cameo in the graphics from the book there. All right, so we have basically this idea, right? Having all these different levels, right? We're going to basically break into our classifications, into different pieces, right? Different processes go at different levels. Now, if we have this, right, we need to worry about a few things. The first is basically how do I allocate time for these, right? So I have, a fixed amount of time. I need to allocate some for the top, some for the bottom, some for the, the next level, next level. That is going to be basically up to me, right? So I need to decide, how valuable are each of these levels. Probably what I'll do is have to basically give most of that resource, right, to the top two levels, right? Those or top three levels, basically the interactive stuff, right? That's where most of my resources should be put. Inside each of these queues, we're also going to need to have some sort of algorithm to do basically the scheduling, right? Because I have, if I need to, run something from this queue here, the question is, I picked the right queue, right, the right queue level. What process that's in there should I actually run next? So. There's a question there at the bottom of the slide. What mechanisms can we use basically to decide these two things, right? Allocate time to basically to pick among what to take out of each level. You can maybe think about that for 1 second. Overall, though, it's relatively straightforward. The idea, right, for the second one is like, well, you can just use a scheduler there, right? So if I want to do something, I could have maybe I could have round robin over here, right? These are round robin. I basically just reuse the schedules from earlier. Round robin to make sure I have low wait time, low response time, and like batch time. Maybe that's when you can do like, oh, this is shortest jobs first, right? Over here, shortest jobs first, right? So I can maybe reuse those scheduling algorithms from earlier to manage each of these individual queue levels. And probably round robin is a good idea for interactive stuff because that'll minimize waiting time. And then short jobs first is going to be better for batch processes, right, or student processes because that's stuff that's, oh, it's going to happen later. I can kind of know everything I need to do. So if I know everything I need to do, I can basically do that ordering by size and get kind of that optimal answer back. So that would be an ideal thing to do there. As far as allocating time, that's going to be ultimately a design choice on how do we want to prioritize things. Probably want to prioritize top to bottom. The next idea I want to talk about is the idea of a multi-level feedback queue. So this is going to be it's going to be similar to what we just saw, but somehow a little bit simpler. So the idea is, right, I basically have these 3 levels, and I can even have more for the sake of just an example. We just have 3 here, and each of these, well, at least the top two are going to basically act like round robin. And then the bottom one is going to be a little bit different. It's going to be first come, first serve. So the idea is that when you run a process, it basically comes and it gets, added to the first level, right? So I have my P0 over here. That's how it starts. The first level here is basically going to be set up as a round robin, right? So this is round robin over here, and you can tell it because it has the time quantum right next to it, right? So time quantum 8, time quantum 16. So P0 is there, right, in the first kind of level. What happens, right, is we basically leave it there for a little bit amount of time, and it gets serviced kind of round robin style. Now, if it stays there for too long, what happens is we drop it down, right? So let's say we give it, 8, 8, 8, 8, and it's still there. In that case, right, we kind of would, exit out, move it down. Well, exit out and move it down, right? So we have now our P0 over here. And now it's in kind of a queue, right, with a higher time quantum. It's still under round robin, right? The same schedule is used for both of these, but the time quantum is a little bit different. Now it can sit there for a little while, right, and then maybe it does kind of sit there for a while. What happens is it gets moved down again. So it gets moved down basically over here to the first come, first serve. So the idea is, right, is that you have this notion of kind of priority baked into there, right? So initially you're kind of given a shot to be a high priority process. So I'm going to give you time slices, really, really frequently. Right, I'm going to give you a chance to run. But then if you show me that you're trying to consume a whole lot of CPU time, I'll make you kind of back off, right? I'll move you basically down to a deeper time quantum, right? That's like, well, you're going to get your time you want, but you're going to have to wait for it a little bit longer, right? Because everybody else in that same queue, right, is going to get that same 16-unit time slice, right? So waiting times are a little bit longer because everybody gets their own time to work. Finally, get down to first come, first serve, right? At that point, it's like, well, your waiting time is going to be a lot, right? Because basically everybody made it there before you, they're going to need to complete out, right? So that's going to be kind of a extensive waiting there. So the idea is, right, your process basically filters down, right? So it filters down to whatever is the appropriate queue for the amount of work that it needs to do. Overall, what we're trying to basically optimize for is throughput, right? I want to complete a bunch of things. I don't want processes, to be stuck in that, or to basically to be in this first queue, right, with a low time quantum. I don't want them to be stuck there forever, just consuming resources, consuming resources, consuming resources. If they're just going to stay there, right? If they're going to stay there, I need to move them down, right, and give other processes a chance to go, right? I want to have as many things basically get a chance to complete as they possibly can. I don't want to be in this situation where it's like I keep on giving something little time slices and it's never able to kind of complete, right? Because it really needs a whole lot of time, and if I'm just slicing little pieces, it's going to take forever for it to get those little pieces. So yeah, basically this is also a baked-in priority, right? So high priority over here, low over here, right? And it goes basically from low to high. Okay, so yeah, and I guess the final note here is generally that this design is set up so that we basically exhaust our top queues, right? So we exhaust our quantum 8 queue before we go down to quantum 16, right? Or first come, first serve. So we're trying, right, to complete those things that were, higher priority, right, where the priority is naturally specified by those things that don't take too long, right? We're maximizing throughput here. So kind of in the explanation here, I've kind of already answered this, right? So we know what this is optimizing for. This is optimizing for throughput. Why is this more useful than a multi-level queue? Well, it's because it's doing kind of this, it's basically being able to split your lightweight processes from your heavyweight processes without any intervention, right? So I don't need to label it with priorities, I don't need to label it with foreground, background. Things that are naturally short will complete first with a high priority. Things that are naturally long will drop down to the other levels and complete with a lower priority, right? So I basically have a way to assign priorities implicitly here if I let them, kind of drop down from level to level. As far as some additional differences from the regular multi-level queue, the main thing is that we need basically a way to migrate, right? So we talked about basically migrating down when I exhaust my time slices. That I probably would need some sort of rule. I'm going to let you take 10 time slices at this level, then I'm going to move you down. Would be maybe one thing we could do, right? Where that's going to be kind of a design choice. The second thing, right, is to have a way to move back up. So sometimes, right, it may be beneficial for like, oh, this thing here, right, I want to jump it back up because maybe, I've emptied the other queues. I want to give it, a higher priority chance, right? So maybe we'd have an algorithm for doing that as well. Okay, so that's kind of two approaches, right? These are two kind of top level ways, right? We can handle queuing or scheduling tasks. One, right, is kind of the multi-level way of background to foreground. Here is basically the multi-level where we're kind of dropping down to these different levels that are just handled by different algorithms and are meant to implicitly determine what the priority is for a process.